All right. Hi, everyone. We are continuing on today with activity 6 and talking about function operations. We're talking about adding, subtracting, multiplying, dividing functions, figuring out domain of them, as well as transforming our piecewise functions. So this first part here talks about your basic combinations of functions. And, when we have this lovely function notation, of two different functions, f of x and g of x, and adding them, subtracting them, multiplying, dividing them, and being cautious, especially with division, to make sure that your denominator does not equal 0. So we have an example here with example A of a linear equation and a quadratic function, and looking at their different functions, and especially being, again, careful with the domain on this one, because we always want to think about what will cause our function to have a denominator of 0. That's where those x values cannot happen, otherwise that would happen. Okay, so a couple of things combining this first portion here and looking at these answers. A is very similar to what we see in the example up above. So to look at some of these pieces, when we add these functions together, okay, what we're basically doing is combining like terms, since they're both linear functions, okay, for part A. For the subtraction, then, just a reminder to make sure you distribute to both pieces here of g, so minus 4x plus, or minus 4 plus x, combine like terms again. For both of these, your domains are all real numbers, because we could plug any old x value in, don't have to worry about it. Okay. With our multiplication, reminder that both of these, think of them as having sets of parentheses. So when you expand them out and combine like terms, you should get the quadratic seen here, which again has a domain of all real numbers. Now, what gets slightly trickier then is the division. So the division itself, not so bad, but we have to take into consideration what value will cause our denominator to be undefined, and that's a value of 4. So a lot of times we want to think about it as setting the denominator equal to 0 and solving, and that's the value that will cause your function to be undefined. So we have to be careful there. Okay. The other important example here is B. Okay, and we're going to go through this piece by piece here. So we're adding in part B here together these two functions, and notice we can't combine anything with the quadratic and the constant and the square root. Here we have to be careful of our domain, though, because the domain on this one is going to be only x values that are less than or equal to 1. Because any x value greater than that would make underneath this radical anything negative is not possible for a real domain. So really we can only have x values that are greater than less than or equal to 1. And again, that comes from setting this equal to 0 and seeing what values are going to make it not possible. Okay. Same kind of idea here with the subtraction. Really all we're doing is changing that to subtraction sign. Again, the domain is x values that are less than or equal to 1. For the multiplication purposes here, when we expand out, just kind of expanding with that square root in there, again, domain, anything that is less than or equal to 1 is all that's possible. And finally here, we have to be careful with this division, because not only is our domain going to be affected here when we're simplifying with anything less than. Notice we took away the or equals to 1 portion of this, because we can't have that denominator equal to 0, or equal to 1 anymore. So that's why it's everything that was in not possible with the original functions f of x and g of x, but now we also have to take into consideration this denominator as well, so it affected the domain ever so slightly. Now here, in order to get this simplification, just to take a little step back, we multiplied by the conjugate in order to get the square root to go away, and then up top we can just leave this like so. I don't have to expand out. Really, we wanted to see here this value to be able to set equal to 0 to again see if our domain got affected. And finally, talking through our last example here for part C. Notice in the original function that they gave us up here in part C, square root of x squared minus 9, from the beginning we want to look at what our possible domain is. So notice that we have to have all x values greater than or equal to 3. And the other original given function g of x, we had to take into consideration that our denominator cannot equal 0. So we had to look here and see if anything was going to be affected. X cannot equal the square root of -2, which shouldn't really affect us because that would be an imaginary number anyway. So we're actually pretty good to go. Everything in our denominator here is going to be okay. So what we have to really take into consideration is just this piece here, that all the x values just from the beginning, before we even start combining f of x and g of x, have to be greater than or equal to 3. So throughout all of this, no matter what, again, this domain is holding. So when we're adding the two, when we're subtracting the two, all has to hold. Same thing here, multiplying the two, it's all holding. And then the division always is, we have to be careful because not only do we take into consideration the original domain, we also have to take into consideration, is anything else not going to work here. So when we do this division, we have to multiply by the conjugate in order to get this to not be in the denominator anymore, this fraction. And this time, not only did we have to consider, again, that original domain restriction, but we also had to consider the fact that this denominator now cannot equal 0. But, lucky for us, 3, anything greater than or equal to 3 is already accounting for the fact that 0 is less than 3. So we can keep rocking with this. It didn't actually change that domain. Okay. So a lot of information to go through, but a lot of just talk about looking at these as domain and range, not necessarily tough simplifying skills, but mostly thinking about domain and range. Okay. Now, the next piece of this lesson is talking a lot about piecewise functions. So just to side note what a piecewise function is, we talked a little bit in class about domains and ranges and how they can be, changed based on the area you're in. So with our piecewise functions, it's kind of that same idea where each part of the graphs is going to have its own piecewise function to kind of be careful of. So what I like to do on this is I like to put the breaks in my graph from the beginning so I don't forget about it. So at -2, we have a domain change. So I'm going to put a line here through -2 so I don't forget about it. And at 1, there is going to be a domain change. And those are our 2 breaks in the graph. Okay. So otherwise, what I'm doing is I'm going to just plot some points like I normally would. So if I look at my calculator, for every x value less than -2 and up to -2 here, I want to consider plugging in points to x plus 3. So if I plug in, for instance, -5 plus 3 is -2. And then -4 plus 3 is -1. -3 plus 3 is 0. And then when we get here to -2 plus 3, we get 1. Open circle here because there's not an or equals 2 sign. Okay, so open circle. So now, at this break in my graph, what I want to do is start plugging into the next equation. So -2 squared is 4, and then -1 squared is 1, and then 0 squared is 0, 1 squared is 1. I'm going to keep this one, again, an open circle because there wasn't an or equals 2 sign on that. So let me make it a little bit clearer. On this one, though, this piece there was. So that's why this one gets filled in. But here we're going to make sure it's open. Okay. Last but not least, if we keep plugging in for greater than or equal to 1, 1 negated would be -1 plus 2 is 1. So actually this is now getting filled in because it happened to be the same point. And then 2 negative plus 2 is 0. 3 negated plus 2. Here we are. So it looks like this is kind of our slope on this one. Okay. Oops, I forgot to connect to these because this quadratic cookie. Now, you have the choice. You could either keep this on here or delete them out, depending on, if you have an easy kind of computer job like me. Otherwise, or if you want to erase them out if it's on pen and paper. Otherwise, you could keep them in. But to show the break, here's our piecewise function. Okay? And the reason that's important because we also want to talk about being able to add, subtract, multiply, divide these piecewise functions. Now we have to be careful with these graphs, because if there is a horizontal shift involved through especially the addition or subtraction process, it may or may not move our graph. So what I want you to do is to move on to page 87, right? And we're going to see some different examples down here, but let's look down at the try these part B, okay? And we're going to consider the two functions they're giving us here, p of x and q of x. And what we want to do is to start this by graphing p of x on the coordinate plane and determining some things. So off in the side of your notes, you can kind of draw in a graph, or if you have graph, draw on your own. I recommend the My Notes section. And we're going to start by graphing this particular picture here. So we're going to have some turnover here at 0 that we're going to want to be careful of. So I'm going to make note of that to myself so I don't forget. And at 0, I'm going to have to turn over. And anything less than that, I'm going to have negative 5 plus 2 is negative 3. Negative 4 plus 2 is negative 2. Negative 3 plus 2 is negative 1. Getting the idea here. And then careful at our turnover spot. We are not including this value at 0. So 0 plus 2 is going to be an open circle. And I can connect those. And then the other part of this graph then was asking for x squared. So 0 squared is going to get the filled in point here. 1 squared, 2 squared is 4. And then we're kind of off the graph. We can drop there. Okay. And again, feel free then, if you delete this out, there's a piecewise. Now, part C then wants us, part B wants us to also talk about some key things here. Domain and range, all real numbers, because we do end up eventually filling this in here. We have a relative 0 here at 0, 0. We have a 0 here at negative 2. Those are both filled in, so those are our zeros. Relative minimum of the graph here at 0, 0, but really, these graphs eventually go off to infinity or positive infinity, so that's not the absolute minimum or anything like that. It's just the one we see on the graph. And they also want us to be able to, for part C, which we're going to do down here, to find the sum, the difference, the product, all that fun stuff like we did in part A. So for C, if we start adding these together, so p plus q of x, what we would be doing is we would be taking x plus 3 and adding it to both pieces here. So x plus 2 and then x plus 3 would be 2x plus 5. And that's, again, if x is less than 0. And then if we add the x squared to the x plus 3, we have x squared plus x plus 3. And again, same greater than or equals to. Same domain on that. So domain, again, all real numbers, nothing's being affected here. Subtraction-wise, if we subtract these two values here, x plus 2 minus x plus 3 and x squared minus x plus 3, we actually are going to end up with negative 1, because, side note over here, x plus 2 minus x plus 3. Distribute that negative, this turns into negative, negative. So we end up with actually negative 1, because these two cancel. 2 minus 3 is negative 1. And for the second part, we end up with just x squared minus, again, parentheses, so x minus 3. And that's, again, if x is greater than or equal to 0. Multiplying these, when we multiply p times q of x, we are multiplying here these two pieces. So x plus 2 times x plus 3, and then x squared times x plus 3. This time we end up with x squared when we expand plus 5x plus 6 and x cubed plus 3x squared. And that's again if x is less than 0 or if x is greater than or equal to 0. Okay. Finally, the division. And for all of these, we've kind of had this all real numbers thing. Notice they wrote it on the first one. I forgot to on these other two. They're all real numbers can be plugged in for x. Okay. But this last one, again, you always got to be careful with division, p divided by q of x. Really what we're doing is we're just going to take our x plus 2 divided by x plus 3, and then x squared divided by x plus 3. But, and this is still holding, we haven't really shifted it at all there. Oops, less than 0, greater than or equal to 0. But this time we have to be careful, our denominator cannot equal negative 3. So our domain here, x, when x does not equal negative 3. Okay, on that. Now, all this aside, part D then goes back to kind of the important part of taking this equation and transferring it 3 units to the left and then rewriting this equation. So what we need to do is we're basically taking all these points that we had right here and everything is just getting translated 3 units to the left. Now I'm going to be a little lazy, part D here, and literally just take this 1, 2, 3 and move my graph like that. You don't really probably have that option, but just to save us a little time, you would regraph it just shifted 3 units to the left, right? This is now D. Now what's going to happen is if we took the original graph, right, and the original graph was x plus 2, and this guy then was x squared. In order to shift this to the left, we know that normally a shift to the left means that this would become x plus 3, right? Because it's always opposite day, as I like to say, with horizontal translation. So left 3 means plus 3. So we're basically substituting in for this x plus 3 for x. Don't forget the plus 2. And then same idea here, we need to put in the x plus 3 for x. So this is going to become x plus 3 quantity squared. So our equation really is x plus 5 and the x plus 3 quantity squared. And notice our point of turnover is no longer at 0. It's over at negative 3. So now that's going to be if x is less than negative 3 and if x is greater than or equal to negative 3. So this ends up becoming our translated function, the graph. Okay, so we really have to be careful to make sure we change this domain, right, when needed. All right. Finally, to summarize some of these findings, but check your understanding to kind of sum it all up. Number 1 is the addition of functions commutative. Yes, it is. We'll kind of skip over that, but yes, this is. Explain the domain of the quotient of 2 functions, f of x and g of x. Well, a couple things here. You always want to consider what lies in the original domain of these guys. So you have to be careful. You want to consider for this one the original domain. So is anything going to make the original functions on undefined domains? So like I said, of just the functions individually. And then you also want to consider where does g of x equal 0, because the denominator of our fraction cannot equal 0. Okay, so those are the 2 things you want to take into consideration when looking for those domains. Okay. Number 3, why is this not a piecewise defined function? Well, for number 3, you're probably at first like, oh, this isn't defined function because these are both horizontal lines and their turnover here at 5, like are horizontal lines functions? Well, normally, yes. Okay, you can have just these two horizontal lines. They're like a step function. Here's one going through 3. Here's one going through 6. The problem is that they're both including 5. These are both closed circles. So that's why it's not a defined function, because there needs to be only one value. It's not passing that vertical line test we like to talk so much about. And then last but not least, a student says that here's the original function, and then g of x is its translation 2 units to the right. So aka x minus 2, right? Think about it shifting over. So I agree. If this is my original function and I'm shifting it to the right 2, this algebra here looks good. Okay. The student, however, is not correct. All right, and the reason being, not this first part here. This is fine, this x plus 2 and this x minus 2 quantity cubed. That's all fine. The problem is this if portion. We also needed to shift that 2 units to the left. So it should be when x is less than negative 2 and, 2 units to the right. So positive 2. And we had to shift it again to the right. So this is what the problem is. We needed to make sure we changed it appropriately here. Okay, a lot of information. Make sure you let me know of any questions you guys are having. And again, just talking about sum, difference, and quotient. Again, be careful of where your denominator does not equal 0. And then, of course, the good old-fashioned piecewise functions, being able to graph and ultimately translate those. Thanks, everyone.